The James Webb Space Telescope has unveiled a shocking revelation. The universe has stopped expanding. This discovery is unsettling because it challenges what we thought we knew about the universe's fate. For centuries, we've been accustomed to the idea of an eventual cataclysmic end, perhaps the end times as depicted in science fiction or even the Bible. But what if the end of the universe is not so different from its beginning? Brian Cox, a renowned scientist, predicted many years ago that the end of the universe might mirror its inception. The telescope's latest findings seem to support this theory, as it reveals that the universe's expansion has come to a halt. The James Webb Telescope allows us to peer back in time to just a fraction of a second after the Big Bang, when the universe was incredibly young, dense, and hot. In fact, we can now observe light that traveled through space before galaxies even existed, offering some of the oldest evidence of the universe's beginning. While this discovery might be unsettling, it's one of the strongest pieces of evidence for those who question the Big Bang theory. Contrary to some alternative theories, such as the concept of a steady-state universe or an eternally fluctuating one, the majority of the scientific community has accepted the Big Bang as the universe's origin. This theory posits that everything started from an incredibly small, dense point, which expanded rapidly in a process known as inflation, happening faster than the speed of light. The universe grew at such a rapid rate that, within moments, it expanded from subatomic size to about the size of a golf ball. A second after this rapid expansion, the universe began to cool, leading to the formation of matter as we know it: protons, neutrons, electrons, and other fundamental particles. But despite the rapid progress in our understanding of the cosmos, our current technology still limits us in some ways. We cannot directly recreate the Big Bang or fully replicate the conditions at that time, but we do have strong indirect evidence, such as the cosmic microwave background (CMB) radiation, which allows us to observe the aftereffects of this expansion. However, the discovery made by the James Webb Telescope poses a challenge to what we thought was certain about the universe's continuing expansion. This monumental telescope provides us with a much more precise picture of the universe, showing us previously hidden phenomena and offering new insights that could reshape our understanding of the cosmos. One major piece of the puzzle is the observation that the universe is no longer expanding at the same rate. While the Hubble Space Telescope previously suggested that the universe was expanding, the James Webb Telescope now shows that this process has slowed or even ceased. This raises an intriguing question. If the universe isn't expanding, what does this mean for the ultimate fate of everything in existence? Some theorists believe that the universe would eventually slow down and collapse back in on itself in a big crunch, while others predicted an endless, slow decline into darkness. But the idea that the expansion has stopped opens up new possibilities. Perhaps the universe will enter a period of stasis, or even a new phase we can't yet comprehend. As our technology continues to advance, we are uncovering mysteries that were once beyond our reach. The James Webb Space Telescope is at the forefront of this revolution, pushing the boundaries of what we know about the universe and its ultimate fate. This could be the beginning of a new chapter in our understanding of cosmology, one that challenges old assumptions and raises new, perhaps even more mind-boggling questions about the nature of space, time, and the universe itself. This video is brought to you by Chartbook VPN, and we want to thank them for supporting this content. Be sure to take advantage of their limited time offer by clicking the link in the description. Your online experience just got a whole lot better. Now, before we dive into the implications of the latest discovery that could reshape our understanding of the universe, let's first examine what we know about this mysterious phenomenon. When it comes to the Big Bang, the most common idea is that it was a violent explosion. Popular media and science fiction often depict the universe's origin as a fiery blast that sent energy and matter flying in all directions. However, this analogy isn't entirely accurate. The creation of the universe wasn't exactly an explosion, and scientists are eager to correct this misconception. For NASA, the Big Bang wasn't an event that expanded into space. There was no space to expand into at the time. Instead, it's better to think of the Big Bang as the simultaneous creation of space everywhere in the universe. Our understanding of this phenomenon also reveals that our universe has undergone a tumultuous period, one that was only disturbed by a process known as reionization. Before this event, our universe was pitch dark. The let there be light moment in the universe came 400 million years after the Big Bang. Yes, it took that long. You see, the Big Bang only created the basic ingredients for stars and galaxies. For the first 400 million years, the universe remained shrouded in darkness because no stars or galaxies had yet formed. It wasn't until gas clouds started condensing into stars and galaxies that the universe emerged from its dark ages. Here's a fun fact. Do you know when our solar system was born? While the universe was in darkness for 400 million years, our solar system formed about 9 billion years after the Big Bang. That's right. Sorry, science fiction movies, there's a big gap between the so-called explosion and what scientific theory suggests. So, how does this affect our understanding of the universe today? Well, contrary to the popular view that the universe is simply expanding, recent findings show that space itself is stretching, not just the universe. To be clear, the universe isn't expanding the way we typically think about it. What's actually happening is the dynamic stretching of space itself, which carries matter along with it. This idea is still complex, but it's crucial to grasp as we discuss what's to come in this video. We continue to use the term expansion of the universe for simplicity, as even scientists often use this phrasing to describe the latest discovery from the James Webb Space Telescope. What's truly alarming is that scientists have discovered that the universe has stopped expanding. This is in stark contrast to what we previously thought. For years, scientists believed the universe was expanding at an accelerating rate. This theory was backed by substantial evidence, thanks to the Hubble Space Telescope. But now, NASA has made a groundbreaking revelation that contradicts this understanding. What's happening to our universe might be something entirely new and perhaps irreversible. While this discovery is startling, it's not entirely surprising. The concept of gravity has always made us question whether the universe could eventually collapse in on itself. Back in the 1990s, NASA and scientists had some compelling theories about the universe's expansion. The key concept was gravity, which still holds true today. But in the 1990s, scientists had little observational data to support their theories about how fast the universe was expanding. They believed that as the universe aged, gravity would slow down its expansion, eventually leading to a recollapse. The idea was that gravity, which pulls galaxies together, would oppose the universe's expansion. This seemed logical at the time. Gravity would slow the expansion as the universe grew. However, everything changed with the advent of the Hubble Space Telescope. The HST was primarily used to study distant supernovae, which provided insight into the universe's expansion. The results were unexpected and left scientists stunned. The data revealed that instead of slowing down, the universe's expansion was accelerating. This discovery was a game-changer. It forced scientists to revisit their theoretical models and dramatically revise their understanding of cosmic expansion. For the first time, they had concrete evidence that gravity wasn't slowing the expansion of the universe. Instead, the rate of expansion had been increasing since the Big Bang.